In part 1, we saw how object-oriented programming was about creating new classes of objects. Now, let's think about creating a class to represent a car. So if we want to draw a whole parking lot full of cars, we don't think about it that way. We think about drawing just one car. Again, the messages are going to be go forward and backward, turn right and left, and render itself. And it's going to know some information about itself, like its position, its heading, the direction it's going in, how fast it's going, style. Let's assume that this is an integer that tells it whether it's a sedan or a truck or a race car or a van. And of course, every car has a color. So we take all of this information, the stuff in the blue box that tells us all about a single car, and the messages in yellow that apply to all the cars in the class. And we wrap them all up and we put them together into one object that we hand to processing called the car. So this little picture represents a car class. This is kind of the generic architecture for every car, and they only differ in the values in the blue box. Each car has its own self-descriptive variables. So how would we write this in processing? Well, we'll start out by turning the 5 descriptors into real processing variables. So position, we could save that as a p-vector with x and y. Heading also could be a p-vector. And to keep things short, I'll just call it dir for direction. Speed, well, that can be a float. Style, well, we said that that's an integer representing what kind of car this is. So I'll just write it out as an int. And of course, a color is just a color. These 5 variable declarations now describe all of the things that vary from one instance to the next. Now somehow we have to tell processing that cars know how to respond to these messages. And as I mentioned before, they're just procedures. Nothing unusual about these at all. So go forward and go backward just get written as go forward and go backward. Right now I'm assuming that they don't have any arguments. And of course I'm not writing out any code for them. And I'm assuming that they don't return anything. So I'm saying that they return type void. Of course, in a real car, we would fill in these functions with some real code. And if they took arguments or if they returned a value, we could easily fix these declarations. But I'm just trying to sort of map out the skeleton of what this thing would look like. So we can also create procedures for turn right and turn left. And we can create a procedure for render. So now we've taken care of all of the variables and all of the messages. We're only missing one thing, and that's some mechanism to make a new car. It turns out that's a little bit of a specialty subject, so I'm going to leave that for a future video. For now, let's just assume that there's some kind of routine in here that we can call that will make a new car. In code, we typically organize it this way. First we have the variables, then we have the thing that makes a car, and then we have the methods. Now I want to finish wrapping this up in real processing code. So let's look in the upper left. We don't really write the word car like that. Instead, what we do is we write the word class, starting with a lowercase c, then a space, and then the name of the class. In this case, car. And then I'm going to squish everything together and wrap it all up in curly braces. Notice that class starts with a lowercase c. That's important. I've capitalized car. There's no rule for that. You don't have to capitalize the names of your classes, but that's a very common convention. So let's review. First we have the word class, followed by a space, the name of the class, typically a space, and then a pair of curly braces. Inside the braces, first we have all the variables that describe an instance. We have this mysterious thing that makes a new car, and then we have all of the things that the car knows how to do. So let me show you how we would use this in practice. So let's assume that we've declared this kind of a car in our code somewhere, and down here at the bottom we have a graphics window. By saying that we have a class named car, we're telling processing that we can create new instances of that class. In other words, we can create a variable of type car. To create such a variable, we create it the way we create every variable. We name the type of the variable, in this case car, and then the name of the variable. I'll call it a red car. If I want to create two cars, no trouble. I'll just make another car and I'll call this one green car. Like a p-vector or an array, these aren't really cars yet. They're just placeholders. To make them a car, we have to call this thing that we haven't gotten into yet to make a new car. And we will get to that. So let's make a red car, and it shows up in our graphics window somewhere. And I'll make a green car, and that shows up in our graphics window. Now we're ready to start sending messages. You'll recall that the way we send a message to an instance is we name the instance, here, red car, follow it with a period, and then the name of the method. Here, the method is called goForward, and it doesn't take any arguments. If I put this in my code, then the instance red car gets the message goForward, and it does something. Presumably, it's going to change its position variables. So let's assume it does that, and in the next frame, the car has moved. It's gone forward. Let's do this again. I'll send the message goForward to the red car once again, and the red car will respond by going forward. Let's try something with the green car. I'll send the green car the message turn left. So now I'm targeting the green car, I'm sending it the message turn left, and the car will do whatever it does. In this case, it will probably change the direction vector, rotating the car 90 degrees. Okay, now let's send another message to the red car. I'm going to tell it to turn right. So it will adjust its own direction vector. And then if I tell the red car to go forward, it's going to go forward in the new direction. So that's the general idea. We declare the class by telling processing what makes up the class. We make instances of the class, and then we send messages to the instances or objects. Of course, I've left off a lot of detail here that we will definitely be getting into. I've also left out the calls to render. In order to have these things actually show up on the screen, I would have to call redcar.render and greencar.render, and it would draw ellipses and rectangles and whatever else it needs to draw itself on the screen. So let's recap. Here's all the stuff that goes into a car: the variables in the upper right and the methods or messages at the bottom. We wrap them all up and we call them a car. We create the class by first saying class with a lowercase c, followed by a space, the name of the class, conventionally capitalized, usually followed by a space, and then a pair of curly braces. First, we list all of the variables that belong to each instance. Sometimes these are called instance variables because they're different for each instance. Then there's this thing to make a car, and then there are all of the methods or messages that the car is able to respond to. This kind of organization is great if we want to create a simulation with hundreds of cars. Then we would just make a big array of instances of type car. Each car is then responsible for itself, and we send each car messages to simulate the flow of traffic. In the following videos, we'll look much more closely at all of the details behind this so that you can create and use your own classes.